Angeles. Today, Kathleen is the lab manager for the Marine Mammal Ecology Lab at WWU and leads a team of undergraduate research assistants to study a novel management tool designed to decrease the predation rates of harbor seals. Thank you.
Awesome. Thank you so much for that introduction. And hello, everybody. My name is Kathleen McKeegan. I would like to take a moment just to thank all of the organizers for putting together this symposium and for the wonderful opening keynote speaker. I'm very excited to be here and to hear what everyone's working on. So as Bridget mentioned, I'm going to be talking about a novel type of hazing device called Targeted Acoustic Startle Technology and its effect on the foraging success of individual harbor seals here in Whatcom County. And the research that I'm presenting on today was conducted by myself, as well as other researchers from the Marine Mammal Ecology Lab and my co-authors, Dr. Acevedo Gutierrez and Kate Clayton. So first, I would like to contextualize my talk within the context of a conflict that I'm sure many folks are familiar with, which is the conflict between pinnipeds and frankly humans, but mostly fisheries, over commercially important prey species. And pinnipeds, so we're all on the same page, that includes seals, sea lions, and walrus. And specifically, I'm going to focus in on harbor seals, which are my study species, primarily because they're incredibly abundant here in the Salish Sea, but they're also generalist predators that consume many species of commercial interest, putting them in conflict with us over access to these important prey species, these shared resources. And primarily, the species I'm going to focus on in terms of that shared resource is Pacific salmon, a taxa of great ecological, economical, cultural, and of course, conservation concern, as many Pacific salmon stocks are declining here in the Salish Sea. And we know that pinnipeds, and primarily, as I mentioned, I'm going to focus on harbor seals. We know that they consume salmonids at multiple life stages, but primarily a lot of research has been focusing on the impact of pinniped predation, or in this case, harbor seal predation, on adult salmon, and specifically focusing on how adult salmon may be especially vulnerable to harbor seal predation while they are migrating through estuaries and river mouths during their spawning migration. And that makes sense, right? These salmon are being funneled into generally relatively small areas, these natural or sometimes anthropogenic bottlenecks, and pinnipeds often aggregate in these areas during those spawning migrations and feed on the salmon at this time. And so a lot of effort is being put into figuring out, first of all, how much of an impact they're having, they being pinnipeds are having on the salmon stocks, but also trying to find ways to decrease this potential impact, try and mitigate the pressures of this predation on the salmon stocks to hopefully allow for recovery of certain stocks. And so with that in mind, a lot of effort, as I mentioned, is going into figuring out how do we mitigate, how do we decrease pinniped predation on salmon. A very common tool that folks use are acoustic deterrent devices, or ADDs. These are essentially designed to use sound to try and deter seals from preying in a specific area. They come in multiple forms. For example, this is a seal cracker, which is essentially an explosive device. And then we also have seal scarers, which are like underwater speakers that play loud pinging sounds to scare the seals away, more or less. There are some issues with these typical ADDs that you see out and about. First, they are, sorry. There we go. They are designed to cause pain. So that can, in fact, cause hearing damage, which harms both the target species, in this case, the seals, as well as non-target species, such as those that are particularly sensitive to noise pollution, such as odontocetes, like dolphins and porpoises. It can also result in deafness in our target species, which is not ideal when you're looking for a long-term solution and you're using an acoustic device. Furthermore, it can lead to habituation, where the pinnipeds just simply get used to it, or they even learn to associate it with prey. So that's what we call the dinner bell effect. It's like a Pavlov's dog. They learn to associate the sound with prey, and so they'll actually come to the sound instead of being deterred by it, which is not ideal. Enter in a new option. So this is the kind of focus of my research right now. It is called TAST, or Targeted Acoustic Startle Technology. And TAST is a new type of ADD, acoustic deterrent device, that was developed by researchers in Scotland, specifically in the Sea Mammal Research Unit in the School of Biology at the University of St. Andrews. And the device is different from most typical ADDs in two primary ways. First, it is using a sound that triggers an autonomous reflex response in seals, and specifically in harbor seals and gray seals. And when I say that, what I mean is they hear the sound and an autonomous reflex response gets triggered where they get startled, which makes it very difficult to habituate to because it's a reflex. It's something that the harbor seals can't really consciously control as much. Furthermore, they can try and target this ADD specifically to pinnipeds in order to reduce the harm to non-target species. So if we look at this chart produced by the researchers in Scotland who developed the device, we have frequency here on the x-axis and then decibel level on the y-axis. And if you look here, this is the range that TAST is operating in. It's a bit of a lower frequency range than most current ADDs are using. So they're using a higher pitch, whereas TAST uses a bit of a lower pitch. And on this lower frequency range, pinnipeds, specifically harbor seals, which are these red diamond shape right here, they are more sensitive to that frequency range at a lower decibel level than other species of concern, such as odontocetes or bony fishes. And so that means, in theory, if you play the sound within this frequency range at quieter levels, our pinnipeds will be able to hear it, reducing harm to other species and targeting the sound a little bit more directly to the predator that we are trying to focus on, in this case, harbor seals. So TAST has been tested in a couple different scenarios, mostly in Scotland around farmed salmon and aquaculture pens, trying to deter harbor seals and gray seals from consuming farmed salmon, where it showed to be relatively effective with pretty significant decreases in predation rates. It was also deployed more recently at the Ballard Locks in Seattle. And then the folks at Oceans Initiative, a local research group here in the Pacific Northwest, was able to get TAST over here to Whatcom County. It was deployed at Whatcom Creek in fall of 2020 to hopefully deter the harbor seals preying on salmon in the creek. Now, this was a pretty exciting opportunity because Whatcom Creek's in a very ideal spot to study the impact of pinniped predation on salmon. First of all, so for context, this is the study site we're focusing on. It's the mouth of Whatcom Creek, which is located in downtown Bellingham. For some context, this is Holly Street, the Holly Street Bridge, if you all know it. This is Maritime Heritage Park, and the creek is flowing in this direction towards Bellingham Bay. Now, the creek, as I mentioned, is relatively small, so you can access it very easily via the public park. There's some boardwalks, there's sidewalks, there's trails, and you can stand on these sidewalks and look out over the creek and observe the activity without needing anything like a boat or anything like that, which makes it very ideal for studying harbor seal activity in the creek. Furthermore, up here, you can see part of the Whatcom Creek Hatchery, which is maintained and run by the Bellingham Technical College, as well as their co-managers with the Lummi Nation and the Nooksack Indian tribe. And they maintain a population of Chum salmon and Chinook salmon that run upriver to spawn in the fall. So we have a reliable salmon population that frequents this creek. And furthermore, this is where the TAST was deployed, right here at the base of the hatchery fish ladder by the folks at Oceans Initiative. And we also have a population of harbor seals that reliably aggregate in Whatcom Creek every fall to feed on the adult spawning salmon. And we know this because folks at our lab, the Marine Mammal Ecology Lab, have been studying this population of harbor seals since 2011. So we have a wealth of knowledge about these seals that frequent the creek. We've identified roughly 200 individuals since 2011, that many of whom are coming back year after year to feed on the salmon. For instance, you can see over here, this is individual 104, who has returned multiple years in a row, and it has come back again in 2020 and in 2021 to feed on salmon. So we have this known population of seals that reliably return every year, but we also know that they're only coming to feed on salmon. And so this graph was produced by the previous graduate student, Grace Freeman, who found, if we look at salmon numbers, which is in this dark black color, versus seal numbers, which are in the lighter gray, over several years between 2014 and 2019, both populations essentially peak in the creek in terms of presence around November. So that's when the salmon are returning to spawn, and the seals only ever show up in the creek at the same time, suggesting they're really only here to feed on salmon. They're not here for really any other reason. Also, since 2011, we've been learning a lot about these seals all the way down to the individual. And we've been able to track their foraging success, meaning seals that successfully capture and consume a salmon in Whatcom Creek. We've been able to track that at an individual level for almost a decade now. And we've noticed a lot of key things about this population here at Whatcom Creek. First of all, there's significant variation between the individuals in terms of how successful they are. So what I mean by that is that some are very skilled hunters, to put it bluntly, and some are not. And you can look at that between these two individuals. We have ID 0039 here and then ID 12 right here. Both individuals have visited the creek multiple years and multiple times each year. They're very frequent flyers, if you will. However, individual 39, we have definitely over 20 instances where we've noticed this individual capture and consume a salmon, whereas ID 12, we have never seen a single salmon consumed by that individual, which suggests that there is this significant variation between our individuals in terms of how much salmon they're consuming when they are at the creek, and also potentially putting forth some evidence for rogue individuals, those that are having a disproportionate impact on the prey population compared to other seals in the population. And those may be a focus for pinniped management strategies. So all of this together created an ideal situation to try and fill some key knowledge gaps in terms of how successful this new type of hazing device, TAST, which almost seems too good to be true, how effective is it? And we can study that here at Whatcom Creek. So the knowledge gaps I was trying to fill, essentially, was that there has been no research on the effects of TAST on individual seals. And this is important because most studies that have looked at TAST so far have looked at the general population and looking at the decrease in predation rate of the seals per hour. But nothing has tracked it across the individual level. And it's very possible, previous research has suggested that some seals may not be affected by TAST to the same degree, and that most predation may be occurring by only a couple individuals within the population. So it'll be really interesting to see how TAST is impacting our individual seals, tracking that foraging success across the individual, and looking specifically at what's going on with those possible rogue individuals that we see at Whatcom Creek. Also, there's been no research looking at the long-term effectiveness of TAST on individual seals over multiple years. Everything has been relatively short-term studies. And we have this wealth of data from 2011 on to 2021 that we can use to assess that long-term effectiveness. And to do this, we conducted observations. So TAST was deployed by Oceans Initiative between October 29th and November 24th at high tide only, because the instrument needed to be fully submerged. They followed a 3 days on, 1 day off schedule. And during that time, our lab conducted 25 observations. Our observations are 2 hours long around the slack tide, the idea being that the water is a little bit more still as the tide is shifting, and so we can observe activity a little bit better. We collect during that 2 hours, every half hour, we summarize what's going on with the population. So how many seals are in the creek, how much fish are they consuming, as well as environmental data like what's the weather, what's the tide, etc. We also continuously throughout the 2 hours are collecting surfacing events data, and that is anytime a seal breaks the surface, we are noting where it is, how long it's at the surface, what it's doing, and if it is consuming a fish or not. And while it's at the surface, we are also taking photos of those individuals to ID them. So we have, ever since 2011, been collecting a lot of photographs of these individual seals. And fortunately for us, seals have unique fur patterns on their faces that allow them to be identified down to the individual level. And so, for instance, we're able to separate unique individuals tracking the right, front, and left side of their faces and create a 4-number numerical ID for each individual seen across the years. So this is an example of individual 0039, the individual I've been talking about quite a lot throughout the presentation. This photo was taken in 2016, and using either the free software called Wild ID, or in some cases manually, when the photo quality is not quite as good, we ID these individuals. And so we try to find at least 3 markings that match to the catalog. So you can see I circled a couple examples here. And once we do that and have an independent observer confirm the identification, we can then say, yes, this is individual 0039 taken in 2019. So as you can imagine, during these 2-hour observations, we collect a lot of photos. So all of those need to be processed in order to make it quantitative data that we can analyze and see how TAST is impacting our seals at the creek. So within that 2-hour observation, we go minute by minute in the photos and we ID each individual seen in that minute. And essentially that gives us a set of information. It tells us presence absence for each individual per day. So for example, 39 was seen on November 1st, but then was not seen on November 2nd, and then was seen again on November 3rd. So we get presence absence per day or per observation. We also get a proxy for duration, which I deem the occurrence counts. Essentially, because we're going minute by minute, we get a relative proxy for how long these seals are spending at the creek. So for example, let's say in 1 2-hour period, we got 59 minutes of photos of individual 39, whereas we got 2 minutes of photos of individual 12. That gives us a relative proxy for how long these seals are spending at the creek. We can also use the photographs as well as our observational data to associate foraging successes with individuals. When I say foraging success, I mean that individual successfully caught, captured, and consumed a salmon at Whatcom Creek during our observation. And fortunately for us, well, with smaller prey, harbor seals can grab and gulp underwater. With larger prey like salmon, they have to come to the surface, and we observe this surface feeding behavior. Because it's so large, they have to process it up at the surface. And so thanks to that, we can grab these photos and identify which individual has a fish at what time and on what day. For example, this is individual 228, and this is individual 79 with a fish. All right, so with all that information, we can start to assess how TAST is impacting harbor seal predation at the creek. I'm going to be sharing mostly preliminary results from fall 2020 specifically. The reason for that is that we did conduct observations in fall 2021 to try and assess the long-term effects. However, those photos are still being processed, so I cannot share that information yet. But when we look at fall 2020 specifically, we can compare TAST on days, those 3 days on, to the TAST off days to see how the short-term effects might be impacting our harbor seals. And so looking just at fall 2020 within that experimental window of October 29th to November 24th, we saw a total of 82 individual seals at Whatcom Creek. And within that time period, during those 2-hour observations, we observed at least 144 salmon being consumed by this population of seals during that month. Individual 173 here was the most commonly seen seal during November, fall 2020. And caught 11 salmon, 6 of which were caught when the TAST was on, 5 of which were caught when the TAST was off. We also saw a couple of instances of California sea lions at the creek, which is not super common for, at least during our observations. We don't see them too often, but we did see them a couple times in fall 2020. And we also noticed at least 2 instances in which those sea lions caught salmon and consumed it, both of which occurred when the TAST was on, which is kind of interesting. As I mentioned, these are preliminary results, so I'm going to be showing you mostly like averages and distributions of the data. I'm still working on running the statistical analyses to figure out exactly how effective TAST is, statistically speaking, but I would like to share some of this information with you all now. So if we look at the impact on the individuals of the TAST, we get some interesting signals coming through. So this graph is showing the distribution of how, on average, how long the seals were spending at the creek when the TAST was off versus when the TAST was on. So on is in green and off is in blue. And this is duration, that proxy for duration using the occurrence counts per minute. And if you look here, we actually had on average individual seals spending about 40% more time in the creek when the TAST was off, and with significant outliers where they're spending quite a lot of time in the creek when the TAST is off compared to when the TAST is on. So we have a lot of individuals show up in the creek. If you look at number of individuals, it's relatively the same between off and on, but they're spending way less time in the creek when the TAST is on. So they are being deterred to a certain degree. If we look at salmon consumed, which is probably the metric that most folks are particularly interested in, we see an interesting story. And the first thing I want to mention is that this is the total number of salmon consumed per individual when the TAST was off versus when the TAST was on across the experimental window. And there's a lot of zeros. And that's just because we're only at the creek for 2 hours during these random observation times. And so there's a lot of individuals that we just don't happen to see catch a fish. So there are a lot of zeros in this population, a lot of no fish caught by individuals. But you do start to see that when the TAST is off, there are more numbers of individuals catching large amounts of fish than when the TAST is on. But we still see significant outliers when the TAST is on, with very, very successful individuals, one individual catching 10 fish when the TAST was on across the experimental window. And so that to me suggests that there does seem to be an impact by the TAST on individual predation success, but there's some significant outliers. So I wanted to look at some of those potential outliers a little bit closer. And to introduce these two individuals, we have ID 39, who is that potential rogue individual that I've mentioned a couple times, as well as individual 217. Now, 217 was new to the creek in fall 2020. We had never seen 217 before, whereas 39 we had seen for multiple years, at least all the way back to 2013, I believe. Very successful individual, catching a lot of fish. 217 was new. So I wanted to see what was going on, because 217 was the most successful individual at Whatcom Creek in fall 2020 when the TAST was on. So if we look at duration at the creek for these two individuals, we have 217 here, and we have 39 here. TAST off is blue, TAST on is green. For 217, time spent at the creek didn't change all that much with TAST status. We even have this outlier up here when the TAST was on, spent quite a long time at the creek. Whereas if we look at individual 39, our potential rogue individual, we can see that there's a significant drop off where 39 spent very little time that we observed at the creek when the TAST was on compared to when the TAST was off. And once again, if we hop over to salmon consumed, which is potentially the more interesting statistic there, this is the total number of salmon consumed per observation for these two individuals. And you can see 217 on average was consuming about 1 fish per observation that we were there. And then when the TAST was on, consumed its most salmon during an observation, which is pretty interesting. As compared to 39, we saw a fairly regular distribution, all hovering around about 1 salmon per observation that we saw. Whereas when the TAST was on, 39 consumed a grand total of no salmon at all. So we never observed our rogue individual capturing a salmon when the TAST was on, which suggests that 39 seemed to be fairly affected by the TAST. It didn't want to hang out at the creek, didn't catch a single salmon, whereas 217 seemed to have almost the opposite, like was not super affected, had its most successful day when the TAST was on. And there's a couple of theories as to why that is, but I still need to kind of zoom in and look at exactly how effective this device is at a statistical level. So it does seem to be that TAST is affecting our individuals differently. It does seem to be affecting the population, but certain individuals maybe not so much, whereas other individuals a lot. And so I want to complete my statistical analyses, figure out exactly what's going on here, how effective is TAST down to the individual level. I want to look at that long-term effect across the years. And then ultimately, I'm hoping that this research will help inform these possible pinniped management strategies, figuring out how useful is this tool within the greater toolbox of hopefully decreasing pinniped predation and allowing for salmon stock recovery in these specific areas. All right, and with that, I want to acknowledge some really key people that have been helping with this research so far. First, my committee members, Matt Zinkraff and Austin Thomas. The entire Marine Mammal Ecology Lab team who have been helping with this research, notably Grace Freeman and Zoe Lewis. All of the folks at Oceans Initiative, primarily the chief scientist, Rob Williams and Aaron Ash, and then the 2 technicians who helped deploy the TAST, Andrea and Stephanie. I want to thank Western Washington University and the biology department, as well as the Bellingham Technical College. And then notably my funders, specifically, I want to thank the North Pacific Research Board Graduate Student Research Award for helping make this research possible. And with that, I would love to see if folks have any questions, and thank you so much for your time.
Thank you, Kathleen. We have 2 questions that are in the chat right now. So go ahead. We have Todd has a question about low frequency sound has been used to herd salmon forever. How do the wild salmon behave when they encounter the targeted deterrent?
That is a fantastic question. And I think it's something that still requires a little bit of study before I would recommend or advocate for this device to be used in multiple river systems freely. I do know that in Scotland during the original test, they did not notice any type of effect on the salmon. At Ballard Locks, they did keep track of the salmon running up the fish ladder when the TAST was on versus when it was off to see if there was any significant change in run numbers, and they didn't notice anything. Anecdotally, at Whatcom Creek, we saw many instances where the salmon were swimming right next to the device and didn't seem to be significantly affected or deterred when the device was sending out its pseudo-random sound signal. And so anecdotally, it doesn't seem like it's really impacting the salmon in terms of their natural behavior, their desire to run up to the fish ladder or anything like that. But I do think that needs to be assessed a little bit closer before it is used freely in different systems.
Thank you.
Mhm.
Next question is from Catherine. Do identifiable fur patterns change with molting or age?
That's a great question, and it doesn't. From what we see, the things that seem to change over time are presence of scars. For example, you'll see a lot of scarring that happens, which you can use to identify because those scars will stay year after year, but they might show up randomly. We also notice that some harbor seals will get blindness in some of their eyes or get cataracts, and that can be an identifiable feature as well. But their fur patterns don't appear to change over time. Granted, we're not seeing pups at Whatcom Creek, so we're not being able to track like from pup to 3-4-year-old, are they changing those fur patterns? But based on the individuals we're seeing at the creek year after year over the past decade, they have not been changing. Yeah, so I see that Todd has a follow-up question. Is it a percussive sound or more constant? So it's more of a, I guess, percussive. It sounds like, I haven't personally heard it, but I've heard other people describe it like kind of a high-pitched buzzing sound that lasts for like a couple milliseconds or a second or so, and it's played at a pseudo-random interval, roughly 3 times a minute, but the seconds between those 3 times a minute change, so it makes it harder to habituate to. So it's like a pulse more than a constant buzzing.
And then Devin has one. Is there knowledge surrounding competition mutualism in feeding between the seals relative to the TAST device?
That's a great question, and something that I know my advisor and I are both interested in because we've been studying these seals for a long time, and we have, more anecdotally speaking, seen some associations between individuals as well as competition. I've seen instances where some seals will steal a salmon from an individual that just caught it. But likewise, I've seen 2 individual seals sharing a single prey item and processing it together. And so in terms of competition and mutualism and feeding between the seals relative to the TAST device, I think that's something that needs to be explored further and would be really interesting. So the follow-up, might that one seal have dealt with negative TAST effects given there were no, oh, interesting. That's, yeah, I think ultimately to summarize my answer to that question, I think that's a fantastic question and something that could be looked at further and addressed further. To give you my hypothesis as to why 217 seemed highly successful. If you know the anatomy of the creek, which I can open back up, but there's this kind of juncture, this corner, where you have the fish ladder on one side and you have this kind of upstream area. And 217 spent most of its time hunting in that upstream area where it very theoretically, very possibly, there was essentially a sound shadow. The sound was not able to turn that corner and go up into the higher falls area. And so it's possible 217 was strong enough to hunt in that area, regardless of the high current, and caught a lot of fish and wasn't affected by TAST due to the location that it was hunting at. So that's kind of my main theory, but there seems to be some associations. There seems to be competition and mutualism going on at the creek. And that's something that I think we're gonna hopefully try and look at a little bit closer in our lab moving forward. So that's a fantastic question.
And then one just really quick yes or no, could these seals have hearing loss, the ones that were more successful?
Yes, long story short, yes, very, very possible, especially in certain areas that have a high history of acoustic deterrent device use, such as those seal crackers or seal scares, which occurs at Ballard Locks. Very likely that a lot of those seals have hearing damage. That wasn't used quite as often at Whatcom Creek, so we don't have the same history or understanding that these seals might have hearing damage. That said, still very likely. I know that the folks who deploy the TAST at Oceans Initiative had some theories. They're like, that individual probably is deaf because they don't seem affected at all. And I'm not sure exactly how we would go about proving that, but it definitely could be playing a role.
Well, that's all the time that we have. Thank you so much, Kathleen, for your presentation. For any other questions, we have copied and pasted those, and we will do our best to follow up. Right now, we're going to head into our first break for morning break. So